So in today's video, we are going to be learning about the second number we can use to quantify the skewness of a dataset or of a distribution, and this number is known as the momental skewness. If you remember, in the last video we talked about the Pearson's skewness coefficient, where the Pearson's formula actually use the mean, the median, the mode, and the standard deviation to get the skewness coefficient of a distribution. When it comes to the case of the momental skewness, we are going to be using the concept of the moment about the mean and the standard deviation to get the skewness coefficient of a distribution. So the formula that defines the momental skewness of a distribution is given as, so let's just say this is a m x, which represents the momental skewness, and we have the formula to be equals to the third moment about the mean divided by the size of the data set, so that is let's use n minus 1 times the standard deviation all cube. So this is the formula we use to define the momental skewness. So like I said earlier, the momental skewness actually depends on the standard deviation and the moment of the mean. So I'm going to briefly explain the concept of the moment of a mean, and in simple terms, the moment of a mean is simply the sum of deviations of each of the variables of that data set from the mean. So we have several types of moments. We have the first moment, we have the second moment, we have the third moment, we have the fourth moment, till we get to the nth moment. So the first moment of the mean is seen as a summation. We have into bracket xi minus x bar, and this is the first moment. The second moment is seen as summation. We have a xi minus x bar all squared. So this second moment can be seen as the sum of the square of deviations. The third moment is seen as a summation. We have a xi minus x bar all raised to the power of 3, and the fourth moment is seen as a summation xi minus x bar all raised to the power of 4 till we get to the nth moment. So we can just say, so the nth moment is going to be summation xi minus x bar all raised to the power of n. So we can write this as the first moment. So this is the first moment right here. Please note that this n right here actually represents the size of our data set. We should keep that in mind. It is very important. So the momental skewness formula can also have a bit of a variation depending on the type of data set that we have. So we can have a momental skewness formula when we have an ungrouped data. We can have a momental skewness formula when we have a grouped data based on class, and we can also have that when it is grouped based on score. It's practically the same thing, just that we have just a few details to just change. So for example, if we are going to be having a grouped data, so let's just take this. So let's just take this towards the right a bit and bring this right here. So let's assume we have an ungrouped data. So obviously the third moment is going to be summation. We have xi minus x bar all cube divided by n represents the size of the data set, so that is n minus 1 times the standard deviation all cube. So the formula for the standard deviation, SD, is going to be equals to the square root of the variance, and that is going to be summation. We have xi minus x bar all squared divided by n. So this is the formula for the standard deviation when we have an ungrouped data. So this is for ungrouped. So we just write an ungrouped data right here. So if we have a frequency distribution, that is, we have a grouped data, and to be specific, a group data based on score. So we are going to be having something of this nature. So let's say a grouped data, excuse me. So we have a grouped data. So in this case of ours, the third moment formula is going to be equals to summation. We have f into bracket xi minus x bar all raised to the power of 3 divided by, so the size of the data right here is going to be equals to summation f minus 1 times the standard deviation all raised to the power of 3. Now the formula for the standard deviation for a grouped data based on score is going to be equals to the standard deviation is actually going to be equals to the square root of summation f modulus sine xi minus x bar squared divided by summation f. So if we have a grouped data based on class, rather, the formula goes like this. So we have a grouped data. So the formula for the momental skewness still remains the third moment divided by the size of the data minus 1 times the standard deviation. So the third moment is going to be summation. We have f into brackets. So we have xmi minus x bar all raised to the power of 3 divided by the summation f times the standard deviation all cube, where the formula for the standard deviation is actually equals to the square root of summation f modulus sine xmi minus x bar squared divided by summation f. And this is these are the variations rather that we can use to get the momental skewness of our data set. If you notice, they are almost the same thing, just a bit of a change in the frequency and some other little details that we paid attention to. So our momental skewness number can also range between -3 and +3, just like we did for the Pearson skewness coefficient. And when you have a number that is tending rather towards the value of -3, it simply implies that we have a very negatively skewed distribution. And when we have a number, a momental skewness value that is tending towards the value of +3, it simply implies that we have a very strong positive skewness. And at a skewness value, or at a momental skewness value rather, of 0, it implies that we have no skewness. And a typical example of that is a normal distribution. So now that we've given ourselves the formula for getting the momental skewness and the several variations it can come with, we need to solve a question. Before I get to the worksheets to solve a question, we need to understand that xmi right here represents the middle class. So that being said, let's move into our worksheet to get the question solved. And this is our question right here. It says that Michael is interested in knowing how much his friend spends on average in a day. He decides to ask each of them how much to spend and gets the following data set. So we have $12, $15, $17, $14, $10, $11, $13, and $15. And we actually want to use this data set to get the momental skewness. The first step is for us to know the type of data set that was given to us, that is the sorting of the data set rather. And we can see that we have an ungrouped data in this question of ours. So that means that the formula for the momental skewness, which is going to be ms, is going to be equals to summation xi minus x bar raised to the power of 3 divided by n minus 1 times the standard deviation of this data set raised to the power of 3. So this is the formula we are going to be using to get the momental skewness for this question. So in previous video, we have been able to get the standard deviation of this data set. So I'm going to be linking a video on how we got the standard deviation of this data set of ours. So according to that video, the standard deviation SD is actually equals to 2.22. So we also need to get the size of the data set, and as you can see, we have 8 of them. So that means n is actually equals to 8. So the only thing we are left to do is to get the third moment of the data set. So for us to get the third moment, we need to get the mean. So the mean is actually the sum of all the variables in our data set divided by the size. So that means our x bar is going to be equals to 12 plus 15 plus 17 down to 15 divided by 8. So I am going to be using my calculator to do that right now. So we have 12 plus 15 plus 17 plus 14 plus 10 plus 11 plus 13 plus 15, and that gives us 107 divided by 8. So 107 divided by 8, and that gives us 13.375. I would like to approximate this to let's say just 2 decimal place. So this is approximately 13.38. So we have our mean. So the next step is for us to get the third moment around the mean. So for the first variable 12, we have a 12 minus 13.38 all cube plus the next variable is 15 minus 13.38 all cube. And now the next step is for us to use our calculator to do the math we have right here. So we have a 12 minus 13.38 raised to the power of 3, and we have our answer to 2 decimal places to be minus 2.63 plus. So let's do for the next 15 minus a 13.38 all cube, and that is a 4.25. So we do the rest that way. So when we do the math of minus 2.63 plus 4.25 plus 47.44 down to plus 4.25, we have our answer to be, and we have our answer to be equals to 1.39. So the third